the agenda for today, we're going to start off with an overview of augmented reality by Neil Trevick from NVIDIA. He's going to show us how open standards and Chronos can contribute to driving the market forward and enabling a market position for augmented reality in devices. Following the overview, we're going to hear from 4 different silicon vendors about how their silicon and systems on chip can contribute to enabling the market for augmented reality in today's devices. And finally, we're going to have a panel discussion. So get your questions ready. We're going to have the panel is going to be led by Christine Perry. And so you'll be able to ask questions to the panel about what augmented reality is and how it applies to the market for today. Okay. Neil?
Thank you, Eric. It's great to see such a great audience here. Welcome to the MWC Moonbase. And we're going to be talking about augmented reality all this morning. And we're going to start out by trying to answer 3 questions. What is augmented reality? When is it going to happen? And why should your company care? And what is going to be the commercial opportunity that it represents? A lot of people have, I think, different ideas about augmented reality and what it actually means. And if you look at some of the industry analysis, things don't look too good, because this is the well-known Gartner hype cycle, which is the way that almost all new technologies that are breaking new ground reach the market. They go through a hype cycle, then reality sets in, but eventually the technology settles out and you get real product shipping in real markets and people make real money. According to Gartner, we're just about to dip into the roller coaster ride, but I don't think that we have to agree or necessarily accept that analysis. And one of my favorite quotes is from Alan Kay at Park some years ago. He said the best way to predict the future is to invent it. And I think that's why we're seeing such a turnout here this morning. A lot of people recognize the opportunity, and I think the industry is beginning to come together to invent the technology pieces and the ecosystem that we need to make augmented reality a real market presence. And this forum is going to focus on the contribution from the hardware vendors, the silicon vendors, which is really, I guess, the first step in a chain of events that we're going to need to make augmented reality affordable and accessible to real consumers in everyday applications on everyday devices. So what is augmented reality, and why do a lot of the analyst community think that it's 10 years away? Well, it is a challenging application. Unlike most other mobile applications, you need all parts of the mobile system to work together in pretty seamless harmony. Now, games on the whole are really just a 3D output kind of thing. Photography and video capture on the whole is pretty much an input kind of thing. But augmented reality is gathering input from multiple sensors that need to be synchronized, that need to be handled in very sophisticated ways to sense what the user is doing, to sense what's out there in the scene and the environment, to track and locate key objects and actions in the environment, create sophisticated data and augmentations that provide useful information to the user, and then combine it and composite it all together, all in real time, all with low power. It's actually a pretty difficult and challenging thing, but we are getting close, I think, and you'll see some of the presentations from the silicon vendors today, where at the silicon level we're beginning to get the capability where this is really coming to be a type of application that is in reach and can start shipping in the market very soon now. Now, this picture is kind of the sci-fi where we would all love to be, with sort of non-existent virtual displays and people just poking and touching them. That's kind of where we want to head. But of course, we have to go through a lot of much more down-to-earth steps before we reach that future. And a brief history of augmented reality on mobile so far, I think you can largely split it up into a number of recognizable advances and steps. A lot of the people here that might have first come across mobile augmented reality probably use applications like LAR or Wikitude, which in their first incarnation at least were based not on processing the camera input, but were based on taking the sensors, the GPS and compass sensors, and then augmenting information about the general locality around the user on a geographic basis. A lot of people beginning to hold their phones up like this, but you weren't locking the augmentations to the pixel level. The next big step was to begin to process the camera input, and the first step along this path of doing camera processing was to be able to recognize and track planar objects, flat objects, and then begin to synchronize augmentations to the pixel level over those planar objects. And you have some marketing applications. You have posters and packages that come to life with augmentations, for example, when you point your mobile device at them. And there are many applications now shipping in the market that do precisely that. I think the next stage that we're looking at now is where the tracking becomes much more sophisticated, and we can track much more than a planar flat surface. We can begin to track real depth in a scene, because of course any environment that we find ourselves in has multiple objects with depth. Things are spaced out around us, and we're beginning to find trackers that recognize that and are able to cope with that extra dimension of complexity. And this is going to be an important step forward, and really we need this to continue to advance to enable these mobile devices to track more and more complex environments going forward. So these visual-based pipelines, what are the key steps? I recognize many faces here, so I'm a little scared because many people in the audience know more about this than me. But for those of you that are new to augmented reality, the basic step is the camera input is used, and it's used in two ways. The first way is the camera input is sent off to the tracking subsystem. Very often the tracking subsystem today is run on the CPU. It's quite sophisticated software, so it needs to run on the CPU traditionally. And you're locating and tracking objects. And you're also taking in the sensors, the motion sensors, the gyro and inertial sensors, and you're generating a camera to scene transform. So you're locking and knowing where the camera is in relation to the outside scene.